Good evening and good morning. My name is Shafi Patel. I'm an IoT evangelist, SME, and trainer. And this webinar on IoT data analytics strategy has been brought to you by Cognixia. So we'll first have a quick round of introduction. Let me first introduce my organization to you. See, we all know digital transformation continues to affect how organizations use and integrate technologies. And current workforce needs to step up to support their company's goals. Cognixia, a digital workforce solutions company, focuses on upskilling workers, technology professionals, keeping in mind the specific requirements so that they gain a significant competitive advantage in the market. Cognixia provides best-in-class learning solutions in artificial intelligence, machine learning, cloud computing, ITSM, DevOps, big data, robotics process automation, Red Hat, VMware, and many more cutting-edge technologies. Our regular updated curriculum ensures that the training remains aligned with your organization's needs at all times. Our team of technical experts brings years of industry experience to the table, which enhances the design and delivery of the course content. No matter what level of knowledge and skill development you are seeking for your workforce or for you yourself, Cognitia has the courses and experts to support your individual and business training needs. So whenever it comes to digital transformation, just think about Cognitia. So this was a brief description and introduction of what Cognitia do. So once again, I welcome all of you to this webinar, which has been brought to you by Cognitia. Those who have joined now, we'll have a round of discussions on this topic and all the subtopics which have been shared with you is part of this webinar information. And then we'll have a round of question answer at the end of this webinar. So please keep your questions ready. We'll first have a 1 hour discussion, and then we'll have a 30 minutes question answer round. So let me begin this webinar with the promises which have been brought to you by these emerging technologies, the technologies of today's era, IoT, big data, machine learning, artificial intelligence, deep learning, cloud computing, and there are many others. This technology promises to transform our world, to make our world better. And one of these technology called IoT or Internet of Things has become one of the most fascinating technology of this era and is also being considered as an industrial revolution. So let me first share basic technical definition of IoT to bring all of you on the same page, especially for those who are new to IoT. So Internet of Things or IoT is defined as the extension of sensing, computing, communication, and actuation capabilities to mundane objects or things. These things range from your shoe to your car, from your home to your city. And when you look at IoT, it's almost everywhere. We have a new class of advanced software applications, augmenting cognitive capabilities of automated systems, and transforming them into autonomous systems, the systems capable of making their own decisions, leveraging automated learning capabilities. This digital world comprises of 50 billion smart and connected things. You can call them the inhabitants of this world. And a new figure has been shared recently, connecting more than 5 billion things or smart products to internet by 2030. So next 10 years, we are going to witness more and more things getting connected to internet and powered by data. Okay. So when it comes to this new generation smart connected objects, they derive this power of learning and making decisions from data. And we all know what does data mean. Right? Data has become the most precious asset of today's era. Organizations care more and more for data, and data is increasingly becoming the primary asset. Data, when it comes to IoT, is defined as the values of attributes characterizing objects and events. I have one of the example here on my screen. A car as an object has model, price, years of manufacturing, color, engine type, and registration number is its attributes. Similarly, all the objects and events in our surroundings, are characterized by a well-defined set of attributes. And these attributes sometimes have fixed values and sometimes have time-dependent and time-variant values. And this is our data from IoT's perspective. So you can say we live in an ocean of data. Every event, every object, whether it's your shoe or your car or your coffee maker or your TV, they all are sources of data for us. Now see, IoT is a technology has provided an opportunity to capture more and more data to benefit from it. But more doesn't always mean merrier. The more data you collect, it becomes more and more confusing. And why I'm sharing this with you? Because if you look at IoT, this term was introduced in 1999 by Kevin Ashton, and it has been there. This technology has been there for more than 20 years. In last 20 years, if you look at the IoT projects which have been initiated, and there are hundreds of or thousands of the IoT projects which have been initiated in last 20 years. But one of the survey has revealed that 90% of these IoT initiatives led to failure. And the primary reason behind the failure of these IoT projects or initiatives was lack of data strategy. A well-defined, well-devised, well-crafted data strategy is one of the component of overall IoT data strategy. And once you ignore it, the failure of the project or initiative is almost inevitable. And this is the reason why we have selected this topic for today's webinar to share the knowledge and equip you with the pointers so that you can architect and build a perfect IoT solution. So let us look at those key parameters and key consideration. But before I share those parameters with you, let me first help you understand the end-to-end flow of data in an IoT system. See, an IoT system is an ensemble of multiple technologies. When you look at an IoT project, architecting and building an IoT project is a complex endeavor. It demands a combination of skills. For example, when you look at IoT nodes, these are the smart things or smart objects with sensing, computing, communication, and actuation capabilities. These IoT nodes are actually an evolution of embedded systems. So you need embedded system professionals to build these nodes and develop applications running on them. Now the second technology component, which is here on my screen, is a gateway. A gateway is an intermediate node enabling low power, resource constrained IoT nodes to connect to internet. It also keeps the IoT deployment secure, and there are other roles played by gateway. The third component that you find in an IoT system is obviously the global communication infrastructure, almost ubiquitous and economical, called internet. And then comes a cloud platform augmenting the computational capabilities of IoT nodes by offering various services. The services could be categorized as computing, storage, and analytical services. So when you look at the IoT data, IoT nodes, they primarily play the role of data collectors. Data collection is done at this end for IoT devices, and one of the type of IoT nodes called sensor nodes collect data from the real life environments. Once this data is collected, the next step is data aggregation. Data aggregation means combining data with data coming from other sources to make it meaningful, making it contextual. Once the aggregation has been done, the next step is data storage. So you need an efficient and economical data storage solution depending on your project's requirements. Then comes deployment of analytics to derive all the hidden valuable information or insights from data. And then you have in the next step, this insights are consumed by decision-making applications. This decision-making applications are applications based on machine learning algorithms. These machine learning algorithms consume insights derived from data in the form of analytical outcomes. And then finally, these decisions are routed back to the second type of IoT nodes called control nodes. These control nodes are responsible for command execution. A control node is equipped with actuators, for example, a smart robot on a factory floor. These control nodes, they execute these commands and manipulate real life environments accordingly. So this end-to-end flow of data, you can also call it a computational loop, from collection to command execution, from data collected by a sensor node to a command delivered to control node for final execution to interact with a physical environment in an appropriate manner. This computational loop can be closed. Now, I'm sharing something that is highly strategic when it comes to IoT deployment. You can have this computational loop closed on your devices itself. When we close computational loop on devices or IoT nodes, this computing paradigm is called embedded computing. The second point where you can close your computational loop is obviously gateway, and closing the computational loop at gateway has given emergence to a new computing paradigm called edge computing, or we also refer to it as fog computing with a slight difference. The third point where you can have your computational loop closed is obviously a cloud. So you push your data from your local deployment to cloud, and then finally data is stored, analyzed, a decision is made on the cloud and routed back to control nodes for final execution. So either you can choose one of these three computing paradigms: embedded computing, edge computing, or cloud computing, or you can make a combination of these computing paradigms. And in most of the cases, we find a combination of these three computing paradigms being leveraged by IoT implementers. So once you have made this strategic decision where and how to deploy the computational loop, then in the next step, before you transform your strategic decision into a physical development, a real life product, or a real life implementation of your idea, there is something that you should never ignore, and this is called data strategy. See, the outcome of IoT solutions. So here in this picture, it is depicted as action. See, these actions are, and you find this in almost all the IoT solutions. These actions are either new feature-rich products or new rich experiences delivered to end user. Now, whether it's a product or an experience, these actions have to be accurate, consistent, and profitable, right? So there are three key primary considerations that you will have to take into account. See, these actions have to be accurate, deterministic, predictable. And why I'm highlighting this point here? Let's take example of a healthcare wearable sending a wrong alert to a healthcare institution to deliver or to send an ambulance. Take an example of your smart car placing an order for a part replacement where in in fact it was not needed. Think about your smart assistant, digital assistant, booking an appointment with your doctor without your consent, or booking a table in a restaurant without your consent or without your permission. Right? This is the reason why these actions have to be predictable and deterministic as well as consistent. Now, if you look at the left side of or left end of this diagram, we have data, and at the middle we have business logic. See, correctness and appropriateness of actions, outcome of your IoT projects, depends on this two sets of parameters primarily. Let us first talk about the data or parameters pertaining to data. You know, as a technology professional, I strongly believe, and I think you would also do, there is a law: garbage in, garbage out. You feed garbage into a technology system, and you cannot expect a good outcome, right? The same is applicable here when it comes to an IoT solution. When it comes to data, the first parameter you will have to take into consideration is relevancy. Let's take an example of an alert delivered to, you know, a service provider. It's an emergency alert, but the location, time, and date information is absent. So an alert will not have any value without time, date, and location tags, right? The same applies to quality of data. While capturing data, while acquiring data from real life environment, you need to keep one thing in mind: your real life environments are always full of inconsistencies and noise. So if you don't take care of the quality of data at the point of capture itself, you will have to spend more time in cleaning and gleaning insights from data. So rather than spending more time on your data to make it ready for analysis, it's better and less time consuming to take care of quality at the point of capture itself. The next parameter that you will have to take into consideration is sufficiency of data. See, as I alluded earlier, the decision-making applications derive their decision-making capabilities from machine learning algorithms. And those attendees of this webinar who are from machine learning domain, they would agree with me, and they might know these machine learning algorithms, they perform better when you feed more data into them. So more data doesn't mean just one type of data. More data means the data should contain, all the possible case scenarios, right? So once you have a large amount of data with all the possible examples and scenarios, and you feed this into your machine learning algorithms, then only you can expect accurate predictions from them. Sufficiency is also needed, because at the end of the data processing chain, in most of the IoT projects, a report has to be produced or a visualization has to be generated. And the quality of the visualization depends on the amount of data that you have captured. So the less data you capture, the quality of recreation, the quality of reconstruction would be of lower quality. So these are just three key points that I have highlighted here: relevancy, sufficiency, and quality of data mapped to actions. On the action side, you need to take care of accuracy, consistency, and profitability of your outcomes or actions. So data to action mapping. This is one of the key component of data strategy. But anyway, this is not the end of story, because there is the second set of parameters. Your correctedness of actions, appropriateness of actions. It depends also on your business logic. Now, this second set of parameters pertaining to the business logic, and business logic means set of computations you deploy on your data. These computations are coded in the form of applications running in a network environment. So an IoT system or IoT solution is a perfect example of distributed computing, where you will have more than one applications playing their specific roles. You'll find applications collecting data, you will find application aggregating data, you will find applications taking care of storage of data, you will find applications running analytical computations on data, and you will find applications, you know, based on machine learning algorithms making decisions on your behalf. And then you'll at the other end, you'll find applications converting those outcomes or decisions into physical actions. This is all forms business logic. Now, when it comes to business logic, and as I alluded earlier, IoT is an ensemble of multiple technologies. And one of the technology which plays central role, pivotal role when it comes to making IoT happen is data science. See, data science means three domains. You can call them technology domains which have come together, and this has resulted into emergence of data science, the science of dealing with data. These three technology domains are machine learning, where we find machine learning algorithms based on mathematical solutions of real life problems available to us in the form of libraries. Statistics means a collection of scientific methods to derive meaning from data. And data analysis means development and deployment of mathematical models on data. So when it comes to data analysis, it's not just one step process. It's a combination of processes, starting from inspection to cleaning to transformation, and then finally modeling the data with a final goal of discovering useful information, the information that can empower software applications to make informed decisions. Now, when it comes to data analysis, or also called data analytics, there are four approaches which could be utilized or leveraged. And these four approaches are descriptive, diagnostic, predictive, and prescriptive. When it comes to our business logics, businesses to gain operational efficiencies from the deployment of IoT, they ask questions. Industries, especially manufacturing industries, to benefit from IoT, to save time and cost for optimum resource consumption, they ask questions. So these questions could only be answered by analytical computations, and more such computational processes are getting automated. So from a reactive approach called descriptive analytics to prescriptive approach or predictive approach, which are more proactive in nature, the data analytics as a domain has evolved. When it comes to descriptive analytics, it answers basic questions. Like we also call it exploratory analytics, and it answers questions like what happened. So if something has happened, you're gonna come to know what actually has happened. And this is the reason why this is an reactive approach. Reactive means something has happened, and now our systems are inquiring and they are going to take an action. Compare this with the other four approaches. For example, diagnostic. Diagnostic answers questions. For example, why did something happen? So it looks at the causes of an event. If an event has happened, what were the causes? The next analytical approach, which is highly popular and being leveraged by IoT systems, is predictive. These predictive capabilities are derived from machine learning algorithms. Machine learning algorithms have been automating this analytical computational processes, and this machine learning algorithms can forecast, can predict. For example, when is a machine going to fail? So machine's failure can be predicted. When an event which is going to happen in future, the likelihood of its happening can be predicted. And the next analytical approach called prescriptive, which is highly sophisticated in nature, automates end-to-end decision making process. This is exactly where this new class of advanced applications, for example, Alexa in your homes, or driverless cars, or a smart assistant like Google Duplex, or a retail solution from Amazon like Amazon Go, this come into picture. So prescriptive is the most sophisticated form of analytics. Now question is, once we have selected one or a combination of these analytical approaches, what next? The next step is you will have to deploy these approaches in the form of applications, software applications. So our software applications are going to perform this type of analytics on your data to power those decision making applications to generate appropriate or corrective actions. Okay, so there's the second set of parameters, which is the second component of your data analytical strategy. Now once you have carefully devised your data strategy, taking all those key points which we just discussed into account, the next step is you are going to architect and build your solution. Okay, so now you have data. Okay, you have your computations, the business logic available to you in the form of applications, properly mapped to appropriate actions. Okay. Is this the end of the story? An answer is no. Why? Because our solution is still on paper. Now, when it comes to converting this into a real solution, you will have to build a technology infrastructure. And we already looked at those components. You will have to select a microcontroller. You will have to select sensors. You will have to select actuators. You will have to select communication interfaces ranging from short range communication interface like NFC or RFID or Bluetooth LE or middle range communication technologies like Wi-Fi, Zigbee, WiMAX, or LPWAN technologies, LoRa, Sigfox, or cellular communication technologies ranging from 2G to 3G to 4G to 5G, right? And at the end of the data processing chain, you will have to select an IoT cloud platform with the set of services. The services are storage, computational, and analytical services, along with the connectors to integrate cloud deployment with your enterprise business applications or user applications running on user devices, for example, mobile phones or even wearables, for example, a smart wristwatch, right? So to build this type of end-to-end solutions from IoT nodes to user devices, including components like internet, your local deployment, gateways, cloud platforms, these are all components of your technology infrastructure. Now, when it comes to building a technology infrastructure which is going to host your solution, the solution mapping data into appropriate actions, there are 5 key parameters which have to be taken into consideration. And I have put this 5 parameter here on my screen. At the bottom, you see those parameters. The first parameter is the technology infrastructure has to be reliable. The reliability of the technology infrastructure is the most important thing. Say a customer, an end user is not going to rely on a solution if the solution is not reliable. I already shared such few examples with you, sending wrong alerts or you know making false or inappropriate outcomes. So these are not accepted. Your system has to be reliable. And one more thing, why reliability is important, because we are not just talking about cyber systems here. The cyber systems are now cyber physical systems. The systems, computers have transformed. Computers are interacting with the physical world now. And this is why the reliability is much needed. The next factor you will have to take into consideration is resiliency. Your systems have to be resilient, fail safe. For example, a driverless car running on highway. What if something goes wrong with the car? The control system, it has to be smart enough to safely park the car in a safe zone, right? Systems have to be resilient. Resilient means system must have a capability to bounce back to normal or near normal condition in the case of failure. The next parameter is interoperability. Now, what does it mean? See, interoperability issues are like ghosts. Once ignored, they would haunt you throughout the lifetime of your system. And here, when it comes to interoperability issues, we talk about technical interoperability, mostly existing at physical layer or data link layer, and semantic interoperability existing at application layers. So your systems and as well as applications running on them have to be interoperable. Otherwise, throughout the lifetime of your product or your solution, this interoperability issues will keep on popping up. The next two parameters, security and privacy, are most important. And the reason why I'm highlighting these two parameters because these two are topmost concerns of technology users. There are several surveys which have revealed that security and privacy are these are two topmost concerns of technology users. So to earn trust of end user, to make them feel feel like buying your solutions or to make them rely on your solutions, you should take these two parameters into consideration. Should always deploy your applications and other computations in a secure and private environment, taking care of security of cyber and physical assets, as well as taking care of privacy of user data. So as you can see here, this picture is depicting all those components, your data to action mapping, including the analytical approaches deployed in the form of computations and hosted in a secure and private environment, an environment created as a combination of the technology component we talked about earlier. So now finally, once you have selected your analytical approaches, once you have built your data strategy, the next thing is how are you going to build those applications? Now, when it comes to tools and practices, the most commonly used tools. So there are several languages, programming languages, and programming environment being used are in practice. But I've selected the most commonly used programming language and most commonly used environment by data scientists, machine learning professionals, and AI professionals. The most commonly used programming language, very popular, highly versatile, easy to learn, is Python. I would also like to highlight 2 points about Python. It's open source and it comes with a community support and a rich set of libraries. There are more than 200,000 Python libraries available to develop Python applications. In Python can be used to build embedded applications. Python is equally useful when it comes to gateway programming. Python is equally useful when it comes to building analytical applications. Python is equally strong when it comes to machine learning or deep learning or AI. And Python is also a useful programming language for building web applications. Right? So This is why I call it a highly versatile programming language. You can do everything using Python. Now, when it comes to Python, there are several programming environments available in the form of IDEs. We have PyCharm, a commercial IDE, but a free version or community version is available. We have other IDEs, for example, Spider, Rodeo, and an easy to use IDE, an open source IDE called Jupyter. Jupyter comes in two forms. Either you can use a web version of Jupyter, or you can download and install Jupyter on your system. And then comes, a package called Anaconda. I'm just going to share Anaconda environment, also called Anaconda Navigator, with you. As you can see, Anaconda comes with built-in IDEs. So there are IDEs like Jupyter, Spider, RStudio for R programming. And if you open Jupyter, you will find it uses your default web browser as its user interface. So Jupyter is a built-in IDE once you install Anaconda, which is a freely available software. Once you download and install this package, it automatically installs Python. It comes with a Python kernel. It also supports other programming language, but Python has got a native support. And with the help of Anaconda and this built-in environment, Jupyter, you can build Jupyter notebooks. Okay, I'm sharing an example of a Jupyter notebook. Here, I'm using Python libraries. The libraries like NumPy, Pandas, ThingSpeak, Matplotlib. Matplotlib is a two-dimensional plotting library of Python. Pandas is most popular data analysis library of Python. NumPy is numerical computing library of Python. And there's one more library which is not included in this notebook, but it's worth mentioning at this point of time, called scikit-learn. Scikit-learn is a machine learning library of Python. So I'll quickly walk you through this notebook. See, this type of developing Python applications for performing analysis on your data are converted into Python code called notebook, and then you can have these notebooks hosted on cloud platforms. Leading cloud platform, for example, AWS and Azure, they offer notebook hosting services. And they also offer high-end machine learning services. Okay. So here in this notebook, as you can see, I've downloaded 4,000 data points from a public channel on a cloud platform called ThingSpeak, powered by MathWorks. It's a weather station. The description, you can see in the description, MathWorks weather station. This 4,000 data points here, it looks messy. Then what I did, I converted these data points here after performing a set of computations called cleaning. I converted these data points into a data frame. A data frame is one of the supported data structure by Pandas library. So as you can see here, I'm using a data frame method called from Pandas library, converting this data 4,000 data points into a tabular data structure called data frame. And as you can see here, we have 8 fields where sensor data have been acquired. Data points have time and date stamp associated with them. So this is one of the most common characteristic of IoT data. IoT data comes in the form of time series. Time series means every data point will have a time stamp attached with it, and this time stamp defines the value of data. Once you lose this time stamp, data will be of no use. Now see here in this channel, field 2 is actually wind speed in mile per hour. you know. So I can share this channel information over here. As you can see, field 2 means wind speed in mile per hour, mph. Okay, there are other fields collecting humidity, temperature, rain, pressure, power level, light intensity, and wind direction. Okay, but what I did, I took this field to data column out from data frame, and then I performed descriptive analytics on this data, calling a readily available method from pandas library. And as you can see here, I have performed this descriptive analytics first on all the columns. And if you don't include all the columns and simply run this, you will have you know a description of all the fields containing numerical data. Now if you look at field 2 means wind speed. You can see here the arithmetic mean, standard deviation, minimum, maximum, 25% of the data, 50% of data, 75% of data. Okay, what do we call them? We call them quartiles. So we have first quartile, second quartile, third quartile. Second quartile is also called median. Okay, now here I have converted this into a plot. This plot is called box plot. So you can do wonderful things once you combine these three things. Python language, Jupyter environment, and Python libraries. So Matplotlib or Pandas both come with this visualization capabilities. You can convert your data into meaningful and informative visualizations. Now, what do you see here? It's a box plot, and the box plot has two ends. Okay, here this is minimum, this is called minimum, this is called maximum, and these three lines here are quartiles. The green line at the middle is median. This is all statistical parameters that you can derive from your data. So the type of analytics being performed here is called descriptive analytics. And here we have a maximum point, and then data points, all the data points which are beyond this limit, these data points are called outliers. Okay, so outlier detection is one of the type of data analytics performed by data scientists. Okay, so data science is a subdomain of IoT. Okay, so the next step, I have converted this data 4,000 data points into a time series, and then here I have plotted data with date and time on x-axis. So this is what you can do. This is just a simple example. I did not select a more complex example for this webinar because of time limit, but there are other things that you can do with your data, including machine learning. Okay, so here we come to the end of our discussion on this topics. Now I'm available to you. In case if you have any questions, a separate question window, right? So let me open the question window. Yes, Ram
Yes,
Gopal.
sir. Yeah, hi, sir. Ram Gopal here. Specifically, if you want to adopt IoT for one is mechanical industries and second one is for medical industries, how best you can adopt it?
So mechanical industry, I also highlighted this point in my delivery.
Yeah.
All types of manufacturing industries are adopting IoT,
Yeah.
to take your systems from automated level to autonomous level.
Correct.
So this is
Yeah.
this is a shift which is there in the industry. More and more systems are getting converted into autonomous systems, to uh, let's say again from this operational efficiencies. So you
Yes.
need to put more less money on the operations once your systems are autonomous, and systems, they start taking care of themselves. So this is one
Correct.
of the idea which is being utilized in the manufacturing industry when it comes to mechanical systems. So should look at this trend from automated systems to autonomous systems. And second thing, as far as the medical industry is concerned, there are two areas where IoT is being leveraged. One is healthcare service providers. They are
Hmm.
getting connected with their customers. I mean to say patients. You know?
Yeah.
So this type of products are being developed, which are being used for real-time monitoring of patients' health, even when
Yes.
patients are not there in the hospitals. And
Yes.
the second area where medical industry is leveraging this technology is high-end data analysis. So we have
Yes.
this high-end solutions like IBM Watson. you know
Correct.
so this IBM Watson kind of solutions, what they can do, they can analyze the data in a much better way to find out abnormalities or any anomalies or any medical issues or problems, health related issues.
Correct.
you know
Correct.
so this type of applications are being developed. Now one of the
Yeah.
solution, even I have worked in that area, the domain called PACS, Picture Archiving and Communication System. And I got an opportunity to work on the implementation of this type of solution in last century. I mean, say 99 to or 1999 in 2000. So
Yeah.
this type of solutions, picture archiving and communication systems, are already there. These systems have now evolved and become much more mature nowadays,
Hmm.
automating end-to-end data analysis, resulting into automated diagnosis and healthcare delivery. I hope this answers the question.
Yeah. One more area where I could maybe say suggest is say where we have to continuously monitor blood cells. Maybe say we want to see white blood corpuscles counts, or maybe say red blood corpuscles count. In such
Right.
cases, we have to continuously monitor the cell mutation. So in such cases, how can we adopt?
So this is one of the area that I highlighted, right?
Huh,
Uh,
huh.
Continuous monitoring. So
Yeah.
this you can achieve with the help of some kind of wearable device. A patient can
Yes.
wear the device so that this parameters or this data can be captured in real time from patient's body, right?
Okay. One is that way. Second method is right. The blood sample will be there in the lab. Now I have to continuously monitor the there is the mutation part and give the analytics. What is the status and how, or maybe say with the data analytics, we have to give the result and saying that the patient is undergoing so and so problem.
Okay, so once
So,
you have the samples available in laboratory, then it becomes much easier, because then you will have a better connectivity with cloud platforms, and you can use all those high-end services offered by cloud platforms, right, in the form of
mm,
analytics.
yeah.
Okay, Ramgopal. So,
Okay. Thank you.
Ramgopal, there
Yeah.
are other participants who are
Yeah.
raising hands.
Thank you.
We answer their questions too. Okay,
Thank you.
thank you. Thank you very much. Okay, so next question I'm taking is from Nagesh. Yes, Nagesh.
Yes, sir. Sir, I want to ask how to implement data science and machine learning to our data, what we acquired from different machines or any kind of sir has told from any person how to use that machine learning and data science.
So I already shared these tools. Python is the best language. It comes with a machine learning library called scikit-learn. Okay, scikit-learn is a good combination, or it is a good collection of all types of machine learning algorithms, from ranging from classification to clustering, supervised or non-supervised. All types of machine learning can be deployed on your data once you have collected data. Okay.
Yes.
And
So
as
second,
a tool, you can use Jupyter. So I already shared this information in the webinar itself, Nagesh.
yes, sir. So second in the how to diagnose anything in machine learning and data science.
So for that, we have a couple of algorithms, So diagnosis means this is one of the analytical approach. Diagnosis means, finding out reasons behind any event, or if something has happened, why did it happen, right? So this information you can derive from data. So this is also exploratory analytics. I just shared an example of describe method. The method shows all the statistical parameters, and also
Yes, sir.
showed you those outliers, right? Those outliers are like abnormal conditions. Okay, so let's take
Mhm.
example. A temperature sensor is being used, and this temperature sensor is collecting temperature data from your room, right? So in your
Mhm.
room, the temperature could range from let's say 10 degrees Celsius to 45 degrees Celsius. This is normal range, right? But
Mhm.
what if the temperature sensor node starts sending temperature values ranging from 100 degrees Celsius to 200 degrees Celsius? So let's say if
Okay.
one or two values or 10 values are beyond the normal range, okay, those values are called abnormal values or outliers. The same is applicable in case of diagnosis analysis, right? Diagnostic means finding out finding out abnormalities, right, or anomalies. So anomaly
Okay.
detection, or detecting this outliers or detecting abnormal values out of beyond normal ranges. This is how data analysis is being used for diagnosis analysis. I hope this answers your question.
Okay. Yes, sir.
Okay, thank you, Nagesh. Please email your questions and I will get in touch with all of you to answer your questions. Okay, Mohammad Rafi.
Yeah, I have a question in regard to is this similar to robotics automation?
So already, we are looking at the next wave of automation.
Okay.
Automation was the word that was coined as in 90s, right? Automation means connecting computers and then computers controlling your physical systems, right? That is called
Yes,
automation.
yes, yes. It is only to the physical devices. Internet of Things is
Yes.
related concerned
Now,
with the thing is that I want to know whether it is connected with only it's a part of the data extraction or anything something like this, or it is only with the devices.
so it is, when it comes to IoT, with the advent of IoT, we are taking automation to the next level, as I alluded in my delivery. Uh, we are talking
Okay.
about now driverless cars, driverless cars like
Okay.
automated cars. Okay. So here we are talking about next level, which is the level which is next to automated systems. An automated system is a system controlled by computer, and most of time these computers are programmed. The applications running on those computers are uh, based on some kind of rules. They derive their decisions from uh, encoded rules, for example, if-else logic. But when it comes to IoT, here we are talking about next level of automation, wherein like we have high-end or next class of applications which make automated decisions. So this is exactly what I was referring to. Autonomous system, a system capable of making their own decisions by uh, you know uh, by learning from the collected data. So this end-to-end computational loop I was referring to, this control loops or end-to-end computational loops, they run on their own without any human intervention. I can share take example of a smart factory. So in a smart factory, the end-to-end processes could be automated, and machines or production systems can work um, without any human intervention. So this is what we are talking about here, Mohammad Rafi. I hope this answers your question. Hussein?
Yes, sir. I have one question. If possible, you can answer me.
Sure.
what is the actual difference between edge analytics and other type of paradigms as you discuss, like fog computing, and another word we have come to know these days, mist computing. Can any difference in implementation point of view?
Okay, it's a great question. And yes, I did highlight these three types of computing, and there are other computing paradigms. So one of the computing paradigm is shared by Hussein is called mesh computing. And there are several other computing paradigms which have been several terms which have been recently coined. Now, one of the term is roof computing. So see, when it comes to this thing, computing means running computations on your data. Now, computing means using a computer to run computations on your data. Now, when you collect, store, analyze your data on device itself, for example, your smart wristwatch, and you are collecting all the data with the help of sensors, you are storing this data on your smart wristwatch itself. You are not sending this data anywhere else. You are storing and analyzing data on your wristwatch itself. So that is called embedded computing. The moment you send data from your wristwatch to mobile phone, mobile phone start acting as an aggregator, where you collect data, you present data to end user, and you also perform computations, analytical computations on your data. In this example, your wristwatch sending data to your mobile phone is acting as a gateway. Mobile phone can also connect to the to a cloud platform on the other side to push data to a cloud platform if needed. So this type of computing is called edge computing. So mobile phone here is playing the role of a gateway or edge computer. In a smart car, you can have one computer collecting data from multiple microcontrollers. You can use a single board computer like a Raspberry Pi with an edge computing solution. So there are edge computing solutions, the form of SDK from AWS and Azure. So this is a second example where edge computing can be leveraged. So let's say if the computer performing computation is within your network, we call it edge computing. If gateway is within your network, we call it edge computing. But if you send your data to a local data center, not to a remote data center like cloud, but a local data center, let's say within a range of 10 to 50 kilometers, and you deploy these computations, you store your data and deploy computations in this local data center within your city or within a close proximity to your devices. We call it fog computing. So this type of solutions are being offered by Cisco. Cisco also offers gateway solutions with fog computing capabilities. So it all depends on how close your computations are taking place. If your computations are taking place within the network, at the edge of the network, we call it edge computing. And if your computations are taking place at a remote place, a remote cloud platform, then we call it cloud computing. And uh, the term that you just shared with me, mesh computing, I like this is the first time I've heard this term. I will have to explore, but there are several other terms. For example, roof computing. So this could be another type of computing when storing data within a network and then performing computations on them. I hope this answers the question, Hussein.
I got.
Okay, so this is the difference is only in where are you storing your data, where are you closing your computation loop. So as I said, a combination of computing paradigms are being used. So there are several computing paradigms out there, but let's not get confused in this interchangeable terminologies. Let us build our data strategy with a good understanding of our data and its computational requirement. I hope this answers the question.
I got, sir. Okay, thank
Okay,
you, sir.
okay, welcome. Okay, the next participant is Anuj.
Yes, sir. I want to ask you something that can I perform IoT program for Arduino-based robot for any particular performing for any particular performer task?
Okay, you want to say, can Arduino be used for real life product development? Is this your
Yes,
question?
sir.
Anuj? Correct
Yes,
me if
sir.
I'm wrong. Okay, good. So it's a good question, Anuj. So I don't see anything wrong in using Arduino, because Arduino boards are based on this microcontroller family, AVR family from Atmel. Atmel has been acquired by Microchip now, and Microchip is a leading manufacturer of microcontrollers. There is one more family of microcontrollers called PIC microcontrollers from Microchip. So this microcontrollers or entire Arduino family of boards are based on AVR family microcontrollers, and these microcontrollers are based on RISC architecture, one of the leading architecture or one of the performance-oriented architecture in the industry. RISC stand for Reduced Instruction Set Computers, right? So there is nothing wrong in building your products based on Arduino boards. Arduino boards are open source, but you should look at your computational requirement. For example, if your microcontroller mounted on Arduino board has enough resources, if it has processing power, if it has memory, if it has a good number of IO capabilities or IO ports, then there is nothing wrong in building a product based on it, right? So it all depends on how powerful the microcontroller mounted on Arduino board is, whether it is meeting you of your processing requirement and data storage and computation requirements or not. I hope this answers the question, Anuj.
Yes, sir.
Okay, thank you. Okay, friends. So do one thing. Please share your questions with support team, coordination team, and we'll be in touch. You can also reach out to me. So thank you very much. Thank you to all of you for attending this webinar, and do contact support team, coordination team for your queries, questions. We'll be more than happy to hear from you, and we'll more than happy to share more information with you about our training programs, and we'll keep on organizing this type of webinars. Do attend those webinars to keep yourself updated. So thank you very much and have a nice day. Bye-bye.